All right, welcome back. Let's wrap up graphing quadratic equations. So we know that in standard form, that's what a quadratic function would look like, or a quadratic equation would look like. We know that it's going to be a parabola, one of these upward opening U's, or a downward opening frown. We know that the vertex is that minimum point or the maximum point. We know that there's an axis of symmetry, and we know that the sign of the A determines whether it opens up or down. If it's a negative, it's a downward opening parabola. If it's a positive, it's an upward opening parabola. We also know how to find the vertex, and we can do that by, first of all, finding the axis of symmetry, which is the line x equals, it's the vertical line, x equals minus b over 2a, which, given whatever equation you have, you plug it in, and you find out that that vertical line in this case is x equals minus 1. Now we can find the rest of the vertex by simply taking that x value, plugging it into the x's, and solving for y. Okay, and you end up with now a point, and that point will be the vertex. In this case, we have an equation. The A is a positive, so it's going to be upward open. And is this the same line? Well, for this example, it's going to be upward opening, and the vertex will be at minus 1 and minus 9. Let's look at an example. Let's graph this equation. Y equals minus 2x squared minus 8x plus 4. So we're going to find the vertex, we're going to use the axis of symmetry, and then we're going to find the x-intercepts. So a bunch of stuff we can do with this. First of all, to find the vertex, you're going to want to remember this formula. This is very important. Just know that. Minus the fraction b over 2a. Plug in your proper numbers. Watch all of your signs. That's very important. Watch your signs. You end up with the x value of minus 2. Now you just go back to that original equation and plug in your x's. And you end up, again, watch all your signs. Be careful. Remember, this squared applies to minus 2, and then it's multiplied by minus 2. Okay? And watch the sign here as well. Make sure you calculate it properly. You end up with a vertex of, in this case, minus 212. We know the axis of symmetry is going to be minus 2 because that's what minus b over 2a was. And since our a value, our a is a minus 2, then the graph will open downwards, right? So we're getting there. Same formula now. Now we can start to actually put it on graph paper. So the vertex we just figured out was minus 212. Put it on a graph. By the way, the scale on this is weird, but they're showing us every 2 numbers. I don't know why they did this, just to confuse us, but they're showing us every 2. Anyway, that's minus 212. Now what we can find, the second step is to find the y-intercept. The point where any graph crosses the y-intercept, we've done this before, is when x is 0. So all you have to do is take your formula and plug in x equals 0. And since these are quadratics, we're going to have a something x squared. That's not a minus. That's just a, like, okay, well, let's say ax squared plus, I'm running out of space, plus bx plus c, right? If x is 0, a times 0 squared plus b times 0, those are both going to cancel out, and you're going to end up with c. So your y-intercept is just basically going to be your c term, whether it's a plus or minus. So in this case, it's a plus 4. Our y-intercept is at the point 0, 4, which we see on the graph, 0, 4, they've put on for us. Make sense? So to find the y-intercept, all you do is plug in x equals 0 and solve. You should end up with your c term. Okay, now, because of symmetry, because we know our axis of symmetry from our vertex, we know our axis of symmetry is this dotted line at x equals minus 2. We can say that since 0, 4 is 2 units away from minus 2, we can also plot the point 2 units on the other side of that symmetry line, and we know that the point minus 4, 4 is going to fall in our graph. And as with everything, if you're given an equation, you could plug in any number for x and find the y value. So here they've done randomly. They've plugged in a value for x equals 1. They've found that it's negative 6. They've plugged in x equals minus 5. They've found that it's minus 6. This is unnecessary. We don't have to do this. We're going to be able to find the vertex. We're going to be able to find if there is a y-intercept. We're going to be able to find the x-intercepts. So that's the next step, is to find the x-intercepts, which happen when the y value is 0. So to find the x-intercepts, we have to set the equation equal to 0, or basically we're going to have minus 2x squared minus 8x plus 4 equals 0. Right, and now we just have to solve this for x. Those will be the points where the parabola crosses the x-axis. And we have any number of different options for this. We can use factoring if it's easy. We can use completing the square if it's easy. Or we can use quadratic formula if it's easy. Whatever you are more comfortable with. Okay? They've shown you down here how to do this by using the quadratic formula. It gets a little sloppy and a little ugly, and you'll notice these points are not the friendliest to us, but sometimes that's how it is. I would probably look at this equation and think, quadratic, I can do that, but is there a better way? Maybe. And I would say, what if I try completing the square? What if I divide everything by minus 2 to get that x as a plus 1 coefficient? So I'm going to have x squared plus 4x minus 2 equals 0. Now I can complete the square. X squared plus 4x equals 2. I want to move this constant to the other side. That's supposed to go to the other side. Right, move that plus 2. Now, I want to create a perfect square trinomial. I take half of my b value. What's half of 4? Half of 4 is 2, and I need to square that. So 2 squared is going to be 4. So I'm going to take x squared plus 4x plus 4 equals 2 plus 4. And now I've got a perfect square trinomial. That means I know that this is the same thing as x plus 2 squared equals 6. Now, use our square root property, and I can say x plus 2 equals plus or minus the square root of 6. I can't simplify the square root of 6 any further. There's no perfect square factors of that. So I can simply say that x equals minus 2 plus or minus radical 6. Which, you plug that into your calculator, you're going to have two values. It's going to be minus 2 plus radical 6 equals blank, and you're going to have minus 2 minus radical 6 equals blank. And if you do that properly, you'll notice that minus 2, I'm pretty sure, minus 2 plus square root of 6 is going to be 0.4, and minus 2 minus radical 6 will be minus 4.4. You'll notice those are the exact same things as what you got over here using the quadratic formula. Okay, so again, just showing you can do it any way that you're most comfortable with. I prefer completing the square if I can, because I don't know, it doesn't matter. Okay, now you've got those values of x equals minus 4.40 and x equals 0.40. Now you can graph those. You've got your y-intercept points, you've got your point by symmetry, and you had your vertex, and you've pretty much got your graph all set now. That makes sense? So let's look at, there's a couple on here. Let's look at one of these as a practice. Okay, let's just do one all together. Let's make sure we do it carefully. So here's our equation, minus x squared plus 2x plus 3. Let's graph this. Let's graph it. It actually should be y equals. Okay, does it open up or down? We have to look at the sign on your x squared. The sign is a negative. That means it's going to open downwards. It's going to be a frowny face looking thing. Okay, what's the y-intercept? This is where we have to plug in x equals 0. So we have y equals minus 0 squared plus 2 times 0 plus 3. You could do all that work every time, or you could realize that those are always going to cancel out, and you're going to have y equals 3. Which means your point at the y-intercept is going to be the point 0, 3. Okay? Now we've got to find the vertex. And the vertex is done by remembering that our x value of the vertex is equal to minus b. It's minus the fraction b over 2a, not just minus b over 2a, but which in this case equals minus b is 2, and 2 times a is minus 1. This is going to be the same thing as minus 2 over minus 2, which is going to equal 1. My x value of the vertex is 1. Now I have to plug that into the function and find the y value. So y equals minus 1 squared plus 2 times 1 plus 3. And remember, the squared applies to the 1, and then you take the negative of it. So 1 squared is 1. We have minus 1 plus 2 plus 3. So y is going to equal 4. So we're left with the point 1, 4 is my vertex. So let's graph what we know so far. We've got an x-intercept of 0, 3. We've got a vertex of 1, 4. 1, 4. That point right there. We know that the graph is going to open downwards. We also know that this line, by the way, is our line of symmetry, meaning that this point has to go 1 unit to get to the line of symmetry. That means you can also graph this point right here, which is actually 2, 3. We've got 0, 3. We've got 2, 3, and we've got 1, 4, our vertex. Now we want to find out where it crosses the x-axis. So find the x-intercepts. So we'll do that down here. That's where I have to set my equation, my graph, equal to 0. So minus x squared plus 2x plus 3 equals 0. And let's see, do I want to take the time to do this with you guys right now? Yeah, we can do this right now. Again, if you are most comfortable with the quadratic formula, you can simply plug this into your quadratic formula. You can factor this if it's simple to factor, or you can do completing the square. And I just want to show you that you always have options. What if I try to make this coefficient a +1? I'll divide the whole thing by minus 1. I end up with x squared minus 2x. Why am I getting sloppy? Minus 2x minus 3 equals 0. And now we can look at this trinomial, and if you're careful, you can remember our a times c equals minus 3 and our b equals minus 2. What multiplies up to make minus 3 and adds together to make minus 2? X minus 3 times x plus 1 equals 0. And now we can simply use our 0 factor property to say that x minus 3 equals 0, x plus 1 equals 0. X is going to be equal to positive 3, and x is going to be equal to minus 1. So the points are actually 3, 0, and minus 1, 0, graphically. Now we just have to put those on the graph. 3, 0 is right here, and minus 1, 0 is right here. And you know what's cool is, if you'll notice, remember our line of symmetry. If you go from 3, 0, you're 2 units to the line of symmetry. You're 2 units back over here. And then we can just simply, and this is going to look sloppy, but we can simply graph. That's the worst parabola I've ever seen, but that's the idea. Okay, but those are the main points you need. You need the vertex, you need the y-intercept, you can find the opposite side by symmetry, and then you can find the x-intercepts. Okay, hopefully that makes sense. That takes us through the end of graphing. Your homework will have a few examples of that. Oh, just so you know, the rest of this presentation, translation of parabolas, we're not going to worry about. 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 What we will worry about next week when I come back is how to apply what we know into word problems and applications for quadratics. And it's relatively simple once you know the main techniques. So we know how to factor, we know how to complete the square, we know how to do the quadratic formula, and now we know how to graph them. Master those concepts from these videos. Have a good week, and I will see you on Tuesday.